You have probably stood in the parking lot of an American truck stop and not really thought about what you were looking at. A Peterbilt or a Freightliner. Big chrome stack, long hood, engine the size of a small refrigerator under that hood. But here's something almost nobody notices. Park that truck next to a European Volvo or Mercedes built for the exact same job, hauling the exact same kind of freight, and the European engine is roughly 2/3 the size. A 15-liter American engine versus a 13-liter European one. Sometimes smaller, same job, same loads, wildly different machines. So why does a country with the same physics as Europe build truck engines nearly twice the size? The easy answer is America is bigger. That is a tourist answer. The real reason is sitting in your kitchen right now, and most people who eat from American supply chains have never connected the two. The full answer involves one piece of 1982 legislation that physically reshaped every American truck overnight, a 1974 weight rule almost nobody outside trucking has ever heard of, and a 70-year-old engineering bet that costs American fleets billions of gallons of diesel a year. By the end of this, you will never look at a long-nosed truck on the highway the same way again. But let us start with what everyone gets wrong about this. The obvious answer is distance. American highways are massive, runs are longer, and so engines have to be bigger. That answer feels right because part of it is true. The average American long-haul driver covers 2,000 to 3,000 miles a week. A run from Los Angeles to Atlanta is roughly the same distance as Lisbon to Moscow. So scale is real. But here is what that explanation misses. A European Volvo D13, a 12.8-liter inline-six, can absolutely cover those distances. Volvo and Scania routinely run trucks from Spain to Norway on engines physically smaller than what is bolted into a Cummins X15. Distance alone does not force the size gap. The real driver underneath is weight, combined with duty cycle. The U.S. federal interstate weight limit is 80,000 pounds, roughly 36.3 metric tons. The EU limit is 40 tons, about 88,000 pounds. Those numbers sound similar. But the way each region got to those numbers is completely different, and that difference is where engine size starts to make sense. Here is where the math gets brutal. American fleets calculated something European fleets did not. A bigger displacement engine, running at lower revolutions per minute under heavy load, lasts longer between rebuilds. Sometimes it can run 1,000,000 miles before a major overhaul. A smaller engine running harder wears out faster. For a fleet putting 130,000 miles a year on a tractor, that durability gap turns into real money. So American manufacturers chose bigger blocks. But that bigger engine was not just chosen, it was allowed by a different law Europe never had. American trucks are not bigger because America is bigger. They are bigger because America wrote a different law, and that law gave engineers something European engineers never had, an engine bay with no upper limit. The real reason goes deeper than weight or distance, and it starts in 1982. Go back to 1981 and watch any trucking movie from that era. Convoy, Smokey and the Bandit, BJ and the Bear. Almost all the trucks are flat-faced. The cab sits directly on top of the engine. There is no long hood out front. These are called cabe-overs, and from the 1950s through the early 1980s, they dominated American long-haul trucking. The reason was a single regulatory rule. Federal law capped the total combined length of truck plus trailer at roughly 55 to 65 feet, depending on the state. Trailer length equaled revenue. Cab length equaled wasted feet. So manufacturers shortened the cab by parking the driver directly on top of the engine. But that compressed cab forced compressed engines. You could not fit a 15-liter inline-six under a driver's seat without raising the cab so high it became unusable. So American engines stayed roughly European-sized, capped by geometry, not engineering ambition. Then came January 6, 1983. President Reagan signed the Surface Transportation Assistance Act of 1982. One section abolished the overall length restriction on the interstate highway system. Total combination length was no longer regulated. Trailer length was regulated separately, with a federal minimum of 48 feet that quickly grew to 53. The cab in front could now be as long as the manufacturer wanted. By 1986, conventional long-nosed trucks were dominating sales. Deregulation had changed the rules. By the late 1990s, cabovers had declined approximately 90% in U.S. heavy truck production. And here is where it gets genuinely strange. The moment that the legal cap came off, American manufacturers had something European manufacturers still do not have: an engine bay with no upper geometric limit. Within a decade, Cummins, Detroit Diesel, and Caterpillar were producing 14-liter and 15-liter blocks that simply could not fit under a European cab, because in Europe, that 1982 deregulation never happened. EU Directive 9653 EC still caps the total tractor plus trailer combination at 16.5 meters, roughly 54 feet. The cab still has to sit over the engine. The engine bay is still constrained by the same geometry American trucks left behind 40 years ago. And this connects to something physically inside your kitchen right now, but we will get to that. So the engine size gap is not engineering preference. It is geometry forced by paperwork. But even after the engine bay was unlimited, why did American manufacturers go bigger instead of just better? That is where the second decision lives. Here's the engineering trade-off most people never hear about. It is called the lazy engine principle. A 15-liter engine pulling 80,000 pounds does not have to work as hard as a 13-liter pulling the same load. Lower revolutions per minute at cruise, lower cylinder pressures, less heat per combustion cycle, less stress on every moving part. The bigger engine is, in a literal mechanical sense, lazier. And lazy engines last longer. American long-haul tractors are typically specified to run 1 million miles before a major overhaul. Some fleets push 1.5 million. European trucks, built for shorter average duty cycles and more urban drop and hook work, do not design for that same brutal, continuous mileage. Mike Roweth, executive director of the North American Council for Freight Efficiency, told FreightWaves the industry stuck with 15-liter engines because of perceived durability, but that the perception was largely just that. We do not actually need that horsepower for most freight movement. But here's where the math gets worse. Even though the industry now admits the 15-liter block is overspecified, that legacy spec is everywhere. As recently as 2019, engines larger than 14 liters made up 49% of the entire over 10-liter U.S. market. Hundreds of thousands of American trucks on the road are running engines engineers now quietly admit are bigger than they need to be. And that is before the historical accident layered on top. The Detroit Diesel and Cummins lineages that became American 15-liter giants did not start in trucking. They trace back to engines designed for tanks, locomotives, and naval ships. Engineering DNA tuned for war, not for commerce. Then came 1974. The federal aid highway amendments raised the gross weight limit to 80,000 pounds and introduced Federal Bridge Formula B, a rule allowing more weight on a truck if its axles spread further apart. So a longer truck could legally carry more. A longer wheelbase made a longer hood, and a bigger engine bay completely natural. Every regulatory choice compounded the last. Length deregulation in 1982, plus the weight rewards for length in 1974, plus the military-derived engine durability culture from the 1940s, all stacked into a single answer: build the biggest engine that fits, run it lazy, replace it less often, and accept the higher fuel cost. And that is exactly why what you are about to hear should change how you see every truck on every American highway. So all of this, the laws, the engineering philosophy, the bridge formula, and the removed cabovers, adds up to something the average American sees 1,000 times a year and never decodes. Now we will see how that history lands directly in your daily life. That bottle of olive oil from Italy in your pantry crossed the Atlantic in a container, rolled off a port crane, and was transferred into a 53-foot dry van, pulled by a 15-liter Cummins, or Detroit diesel. The European producer who pressed that oil loaded it onto a 13-liter truck inside Italy. Same bottle, 2 different displacement classes, depending on whether it traveled before or after 1982. That Amazon Prime box that arrived 2 days after you ordered was hauled at some point by an X15 or DD15 engine. The price of milk at your store is set partly by fleet diesel costs, which are in turn shaped by the displacement choices permitted in 1982. That European spec man or Scania you see in a movie set in Berlin cannot physically pull a 53-foot trailer through most American supply chains without modification, and its chassis cannot accept a US spec 15-liter block. The 2 trucks are not different versions of the same thing. They are answers to 2 different legal documents. So here is where you actually land. You started this thinking the gap between American and European truck engines was about geography or culture, or that America simply likes big things. Park that 15-liter Peterbilt next to a 13-liter Volvo one more time and look at what you are seeing. You are not looking at 2 engineering preferences. You are looking at a gap. You are looking at the Surface Transportation Assistance Act of 1982 made physical. You are looking at the 1974 Federal Bridge Formula rewarding length with weight. You are looking at a post-war engine durability culture inherited from tanks and locomotives. You are looking at EU Directive 9653 EC, written on a different continent, capping total length and forcing every European truck to keep its engine under the cab. 2 engines, sized by 2 completely different sets of laws, made physical in steel. The truck pulling the freight that stocked your kitchen this morning is bigger than its European counterpart, not because Americans wanted bigger trucks, but because Congress wrote a different sentence about length 43 years ago, and engineering followed the paperwork. You are not just looking at a diesel engine, you're looking at archaeology, regulatory archaeology, hidden in plain sight on every interstate. If you think the engine size gap is strange, wait until we get into why American highway lanes themselves are wider than European ones, and the single 1956 decision that is the reason your morning commute exists at all.